Hello everyone, welcome back to Year 9 Mathematics. Today we're going to be solving simultaneous equations using the graphical method. We're going to be solving two equations at once. These are called simultaneous equations because both equations must be true at the same time. They're going to be solved them by graphing. So let's look at our graph right here and let's look at our equations. Let's zoom that out. We have the Cartesian plane, we have these. So let's look at our equations. Y equals 2x plus 1 and y equals negative x plus 7. Now each equation gives us a straight line. The point where the two lines cross is the answer that satisfies both equations simultaneously. So what I want you to do is you want to be plotting at least 3 points per line. 2 points define a line, but a third point will catch mistakes. Now, for line number 1, we have y equals 2x plus 1. When you are plotting, we are plotting for this green one right here. So please follow very slowly with me why there's a table of values here. You can check that out. These are all just to double check. I'm gonna do it for you. When x is 0, y is 1. We plot this point. When x is 1, y is going to be 3, so we plot this point. When x is 2, we plot the following point, which is going to be 5 here. Okay, we're going to draw that out. We're going to draw this line out because we're going to connect these 3 points together and connect them. This is our first line going uphill with a gradient of 2. Remember this. Positive gradient goes up, negative gradient goes down. So line number 2 is y equals negative x plus 7. So when x is 0, y is 7. When x is 1, it's 6. When x is 3, it is 4. So right here. There you go. So plot these 3 points, connect them, and that is going to be our second line going downhill with a gradient of -1. So what I want you to do is to look at where the two lines cross. They're going to meet at these points right here, which I'm going to circle. They're going to meet at the lines of x equals 2, y equals 5 right here. And the intersection is the solution. The answer is x equals 2, y equals 5. This is it, really. But, of course, when you're in doubt, you draw it out, of course. Yes, we know that. That's a classic of the channel already. We're plotting this. The intersection is the solution, but we also are going to check by substituting stuff back as well. So, let's just try it out. So, we have y equal 2x plus 1. Now, we need to substitute them back. So, 2 multiplied by 2. I'm going to substitute 2 into here. So 2 multiplied by 2 plus 1, this will give me 5. Okay, that's very correct right there. What about for the next one? For y equals minus x plus 7. So I'm going to y equals minus x plus 7. I'm going to substitute 2 into here. So minus 2 plus 7 should give me 5. Yes, that's both correct. I have tested for both equations. They satisfy each other. And that should be fine. Now, what I want you to do is you can also try this out for a simple problem. Let's say, for example, you can try y equals x plus 1, and then you can try y equals 2x plus 10 minus 2x plus 10. Like, build a table of values for each, plot both lines, and read the intersection. Where is it? Like, you should have something like this that is pre-built here when you're solving this using the Cartesian plane, using the graphical method for simultaneous equations. Okay, and to end it off, today's habits, always remember for using the graphical method, always plot at least 3 points per line to catch your mistakes. And remember, the intersection is the solution to simultaneous equations. I'll see you in the next video. Thanks for watching.